All right, welcome everybody to week 10, day one. We're going to be talking about two different things today. First thing we're going to be talking about is visualizing data. So, for your homework assignment, you need to do a little bit of data science, a little bit of analysis. You need 9 data points from your program. And so, what I'm going to get from you guys is not really, there's no like input test or anything like that. It's not like our normal assignments in this class. What I'm looking for is something along the lines of like, uh, you know, if you live in the EU, you suffer a negative $10,000 salary penalty, right? That would be like an example of analysis, right? Analysis. Yep. And then you can have data points to back this up. Like you could have like EU entry level is 50,000 average. US entry level 60,000. I'm obviously just making up numbers here, average, and then do the same for mid tier and high tier, and that would be like six. That'd be like 6 bullet points, 6 data points, a little bit of analysis. Do one more of those things, like maybe fully remote, analysis. Remote positions are, maybe they don't seem to have any effect on salary. Whatever. I haven't done the analysis myself. I don't know what's right, so I'm just making things up here. But you could back it up with like 100% remote, 80,000 average, 50% remote, 75,000 average, 0% remote, 82,000 average, something like that, right? So basically, I'm just looking for nine. There's 9 points for 9 data points, and then the 10th one is for doing the report. Now, some students are asking, like, how do I graph things? Like, how do I go about making a graph? And so the easiest way of making a graph is by using. Do you want our code? Your code is going to output like these numbers here, like 80,000. So like on average, 100% remote positions pay 80,000 a year, and you're going to have to be careful to like make sure you're doing an apples to apples comparison. So like, maybe the remote positions are more senior than entry level. And so you have to like do something like this where you're like, you can't just say EU jobs versus US jobs because maybe the EU jobs are more entry level or more advanced. And so you'd have to like account for different amounts of entry and mid and senior tier positions in the different things. And so that's the data points that I'm looking for. Your code is going to produce these numbers, like 50,000 a year on average in the EU for entry level positions. Your analysis is going to be looking at those data points and coming up with a higher level explanation, a higher level description of what is happening. Can you hear me? Testing. Okay. So this is the kind of job that I did for a number of years. There are jobs called data science jobs, evaluation jobs. These are like entire careers, and one thing that a lot of students don't know is that you can get a job using your computer science knowledge and skills, but you're not like doing computer science. Like you're not working for Microsoft making the next Microsoft Word. You're not working for Blizzard making the next World of Warcraft. I made a lot of money over the years by using my computer science skills to do things that my competitors in evaluation didn't know how to do because they didn't have a computer science background. And so what they would do is they would issue tens of thousands of surveys to history students every year. And they only asked 4 questions. And that was supposedly to assess their total knowledge of US history knowledge. 4 questions. And they'd only do it once. At the end of the year, they just give it to all the teachers in these federal programs. And then they would say, all right, students of teachers in the program do better than students of teachers not in the program. And it's all well and good, but at the end of every year, they'd get back tens of thousands of pieces of paper, and they'd have to grade them all by hand, and it would take them forever to do it. And they're only, again, asking 4 questions, and it just wasn't very good. Whereas I, with my computer science skills, was able to make a website and have 30 questions on it, and I could do pre-post testing so that the students would be tested at the beginning of the year and at the end of the year, and then we can measure the difference in student test scores. And then we could break that down by teacher, by district, by county, by state, by program, whatever, to answer the question of, for every $1 million the US government puts into history education programs, how much bump in grades do we see? How much bump in content knowledge do we see? And this is not exactly computer science. I mean, I was using computer science. I was writing programs and websites and databases and all this stuff. And it was just me. But it wasn't like a computer science job. Like, you're not going to see this advertised on, like, you know, as a computer science position anywhere. But it paid really well. And I was able to do things faster and more accurately and with more detail than my competitors because I knew computer science and they didn't. So I was very popular with people. And you know, when you develop a reputation as being somebody who can get the work done on time, under budget, then you have a network of people you know. But they also have a network of people they know. So your clients will tell each other, like, hey, by the way, there's this guy, Bill Kearney, who does a great job. It's fast and responsive, and he's a nice guy to work with, and things like that. And then they'll start hiring you as well. And then, you know, once you kind of start developing a reputation for yourself, then you can just kind of keep on keeping on. I just got an email a couple days ago from somebody I worked with 10 years ago saying, like, hey, you want another evaluation job? I'm like, sure, yeah, why not? I'll take it. It's only for $6,000 a year plus travel. Not a lot of money, but like, it's just a little bit of work too. So, you know, basically, you know, like I'll work with one district and they'll tell the other district about me. And then, you know, I did this for like a long time, like over a decade. I did this and made good money and didn't have to work especially hard. There were times when I'd work very hard. There were times when I'd work 80-hour weeks. But a lot of the weeks, like, I'd have nothing to do. I'd play video games or go to the pool, you know? So, uh, basically, I'm stronger, I'm smarter, I'm better. I am better. No, you don't want to be that guy in a job interview. Trust me. You know, one of the most important things in a job interview is just to have a good attitude and just show that you're going to work well with other people. So, like, if you're hiring, like, it's also different when you're hiring a contractor and hiring somebody to work with your company. You know, if you're hiring a contractor, you want somebody who can do two things: do the job and do it on time, and under budget. You know, like, basically that's it. Like, you know, and you're reasonably well, you know, good communications, well spoken, easy to work with, that kind of stuff. When you're hiring somebody for your company, you're also hiring somebody that you're going to be spending 8 hours a day with, you know. And so if the person has terrible garlic breath, you might not get hired, right? Because they just don't want to be around you for 8 hours a day. Whereas with a contractor, you know, you show up every once in a while, and, you know, if you have garlic breath and whatever, he gets the job done. So contractor work is way better. Yeah, it's less, you know, it's less predictable, right? It's less regular, you know. So you get these spikes of, like, work where you're just, like, working crazy hard. And then you get downtime where you're not working especially hard. And I actually liked it a lot. This whole professor thing is like a retirement gig for me. It's you know, mostly because I enjoy teaching. So data science evaluation, a lot of jobs out there, a lot of contract jobs available as well. I'm a member of the American Evaluation Association, or at least I am sometimes when I remember to renew my membership. Okay, so let's say we wanted to graph some stuff and put that into a report. So I don't have Excel. Let's see here. Okay. So Microsoft Excel is kind of like your go-to graphing tool. The general thing that it's going to be looking for is, like, this format. It's like, let's say that you're doing your classic tomato science experiment where you, like, have different tomato seeds in different cups. You put different amounts of fertilizer into it. And so, like, you put 10 ounces of fertilizer, 20 ounces, 30 ounces, 40 ounces, 50 ounces of fertilizer, and the tomato grows, you know, like something like this. So height in meters. And then this is like ounces of fertilizer or something. So what you do is if you have your data in this format, Excel knows how to understand it like pretty well. You can have different series too, like you have the weight, maybe weight in ounces or something. I don't know. And then you can select all this and you can graph it. And you go to graphing by clicking on insert. And then you can pick which kind of graph you want. For this one, it sounds to me like a line chart. So I'll just do something like that. 2-series line chart. Make sure that you label your axes and your titles and things like that. I always got in trouble for that in physics because I always forget. I put down like time for my x-axis, but I wouldn't say time seconds. You know what I mean? So I try to be pretty good about that. So this is height in meters. This is weight in ounces. And this is like tomato plant growth versus fertilizer. Something like that. And then we're missing the axis here. The axis of evil. So let's see if we can find where that is. No, not you. Here. Axis titles here. And then now we can edit that. So just double click here. And this will be like height. Actually, we don't need it, do we? Because we have it here. Yeah, okay. So this one, though, this is fertilizer in ounces. Okay, so we can see as we add more fertilizer, the plants get taller and their weight goes up as well. So instead of having a y-axis over here, they're kind of like down here. We got 2 different series, and there you go. And so what you can do is just copy this, Control-C, copy, and go into Word, and Control-V, and there you go. So that's basically all I'm looking for. A page, 2 pages, somewhere like that of data science. And again, really the purpose of this assignment is to kind of like have you get more practice doing vectors, file IO, but I'm also kind of trying to give you a little bit of a taste of the whole data science field or the evaluation field and things like that, and how computer science can be used to sort of like enable jobs not considered computer science, not traditionally considered computer science. Most people who are in the evaluation industry are like professors that have studied stats, and then they just work as an evaluator on a grant and talk to people. And I would talk to people too. Like, I always believe in going above and beyond when I'm doing work. So even though I didn't have to be there, I would go into every workshop and observe the workshop and watch the people giving the workshops and talk to the participants and do focus groups and all this stuff. I didn't have to do it, but I always felt like you should always kind of do a little bit more than what people expect of you, and that's kind of a good kind of philosophy for doing work. Always do more than they expect, and then they'll kind of like you more. So any questions about the homework? This will be due on Wednesday, I think. So see if I can find a CSV file or something. Okay, so I went on to Kaggle and downloaded the data science job salaries. I know I have it on my computer here. I can find it. So let me pull that up. And here's a CSV file for the data science salaries. Now let's say I wanted to get a kind of an idea of like what the salaries look like in US dollars. So I'm going to select just this column by clicking right here. That selects the whole column. I'm going to go to insert, and I'm going to do a histogram here like that. And data science job salaries as the title. And it does a histogram, and it's grouping them in kind of like some weird groups. I'm not really sure I like that exactly. See, over here, bin width 29,000. Just making it even 20,000. And so this will be from 42,000 to 62,000 a year. And so you can kind of adjust how finely grained the histogram is, but yeah, it's kind of an idea. So you might want to do one of these graphs for like all the entry level positions, all the mid level positions, all the senior level positions. So you don't just have like the average salary but also you can see the curve of like what the range of the salaries are. There's a position paying 582,000 a year. It's pretty good. This one's paying 322,000 a year. You can see very few of them pay over 260, but even if you're like looking for good jobs over 200, like there's a 23, 11, 6, 3. So you've got a good chunk of jobs that are actually over 200K in data science. And so not only is this assignment teaching you how to do a little bit of basic data science, but it's also encouraging you to do data science because the salaries are not terrible. It looks like the midpoint here is around 60 to 100, somewhere like that. But you can see there's actually quite a few jobs that are in the upper tier as well. Okay, so that's going to end the data science part of today's lecture. Do you want us to write any specific sentences? Nope, you just have to do analysis. So what in plain English, what did you discover about the data? Right? Maybe you discover that working remotely costs you a lot of money. So you'd be like, my analysis is that working remotely is like an average of like a $20,000 salary loss. It's not worth working remotely or something like that. Would each histogram count as one data point? No, the whole histogram is a data point. Yeah. Not each bar in the histogram. Yeah. So, yep, I'm not going to look at your source code. You don't have a directory for it. This is purely like giving you a taste of what it's like to be an actual computer scientist doing data science kind of stuff. Grab some data, write some code to process it, load it off disk, do some stats, spit out some numbers, put it into a report. Every year at the end of the project year, I'd click a button, go to Starbucks, come back. The analysis would be finished 15 minutes later. It would be processing hundreds of thousands of quiz questions and things like that, doing all these statistics. And then I would print it out, take it with me down to FCOE downtown, and over the span of an evening, me and Sue Beloin would sit there and write up a report together and go over all the numbers and write up analysis of what it means and what this means we're doing good at, what we could be doing better at, what we're going to change, that kind of stuff. And it's pretty good money. So, all right, so that's it for this part. We're going to switch over to pointers in 1 second.